So I'm Stephen Woods. I'm the operations associate at the Center for Post-Carbon Logistics. And for today, we're going to talk about, as Professor Golden mentioned, a human scale intermodal container. Now, there is a real need for these. And with people familiar with the maritime field, I probably really don't need to go over the advantages of containers. They've really been the standard for about 50 to 60 years because they save time and labor, they increase safety, they allow lift on, lift off, and switching between modes very easily. Uh, these are all things we're pretty familiar with. They're the Legos of cargo movement, which is pretty good. Makes it nice and simple, very modular. But they do have some significant downsides when you start looking at a sustainable transportation system, and especially a regionalized transportation system that needs to be operating at zero carbon. And with your standard 8-foot wide, 20-foot or 40-foot or more shipping containers, there's a couple of major problems with them in this context. If they're not absolutely full, they leave a lot of broken stowage. And that can be a serious problem when you're looking at making the most efficient ship for a route, or if you're using a small ship. They're heavy, they're energy inefficient because you have to lift 3 tons per TEU additional for every draft on and off of a ship or haul it around anywhere. You need a lot of extra materials to build the containers and carry them around. And that requires a large amount of infrastructure. In an urban environment, they're also wide and long, which makes them space inefficient for many of the scales of delivery that are being done. These are really designed for macro movement of cargo across very long distances and in very large volumes, not really that end delivery when you look at like urban package delivery or final deliveries to a retail store. So that is a different challenge that will be playing out as we make this full-scale transportation system change. And for typical shipping containers, they're also just heavily fossil fuel reliant. They were designed around fossil fuels, or they're very energy intensive. And that goes into the cranes, which are being electrified, and other tools. The trains and the trucks that they're designed around are also fossil fuel heavy. So we need to be aware of these problems and 2 other major problems with ISO shipping containers in a sustainability context. The really big one is Jevons paradox, which was identified first in 1867 when looking at coal consumption, where an increase in efficiency leads to an increase in overall resource consumption because your demand for the increase in efficiency. This is a big thing with transport, especially with containers, because they reduce the financial cost of transportation so much that we do a lot of transportation that's not really necessary. We do a lot of transportation that is, from an energy standpoint, rather silly. And since energy is going to be the big thing in short supply as we make this energy transition, we need to keep that type of efficiency in mind more than finance or labor efficiency. The other big one is we don't necessarily know what's in containers. Really big ones give an opportunity for a lot of smuggling, mislabeling, incorrectly labeling things like hazardous goods, which create problems. But still, there's a lot of advantages to containers, and we want those benefits. We want to minimize the downsides. We have this juggling act that we really want to do here. The answer for a regional and sustainable transportation system isn't to not use containers because they have those advantages. It's to use smaller containers that are more sustainably built and more sustainably handled. And this can be done a couple of ways. When you're looking at what vehicles these containers would work with, it's not trucks, trains, and ships. It's really small ships on regional routes or across harbor routes or something of that nature, cargo bikes, and light electric vehicles. So you can't make them capable of carrying 12 or 13 tons because that's just not going to work with the scale of transportation you're working with. And the lowest weight capacity vehicle there is the cargo bike. So you kind of have a cap at 200 kilos of max gross weight, which needs to be kept in mind. If you want this to be adopted ever, it needs to be compatible with the systems we already have. So that means it's got to be backward compatible with things we already use, and it has to be easily forward compatible with other things that may be developed. It's got to work with capital intensive tools that people already have. It's got to work with trucks and other things that we currently have, but may be modifying or phasing out over the next few decades. And critically, it's got to be inexpensive and sustainable, and it has to be lift on, lift off capable. These are all challenges we can overcome. In looking again at the cargo bikes, this is a drawing from the open source design by Carla Cargo. It's a pretty simple design, but it's rugged, it's popular the world over. And if you look, these dimensions are all in millimeters, but you've got about 1600 by 650. That's the type of size that we're looking at for these containers. And this is another similar one, which is just about half of the length. So we're looking in that range, but again, we want this to be compatible with other systems that already exist. Conveniently, there's some systems being put together that actually bridge all of this. Current pallet standards work really well with cargo bikes using lighter loads. This is the Intermodel system out of France. It has a fork that you can see in the bottom of the pallet, and then you just rock this bicycle trailer onto it, and it picks it up, and then you rock it right back off at the intended destination, and there you go. So this is like halfway to what we're looking for, built already in France. It's available in multiple widths for multiple widths and types of pallets. So what we want to use as a standard for these micro containers and sustainable transportation containers really is the pallet standards that we're used to. Now, this is the standard Euro pallet. It's 800 by 1200. A typical US pallet is about 1000 by 1200. And the Euro pallet also comes in an 800 by 600 half pallet. So those are basically the three sizes that we're looking at the moment for these containers. The Euro pallet system also has a whole bunch of sub-containers that stack neatly on that same footprint. So this would take advantage of those as well, which a lot of the smaller elements of the logistics chain already use. So that's a large amount of backward compatibility built into this. And there's a use case already where these were considered. Back in 2020, Time's Up in Austria was going to do a sail freight project on the Danube, moving vegetables from a CSA, community supported agriculture farm, into the city of Linz. And then it was going to be delivered by bike. And they really wanted a container a lot like the one that's on the back of that tricycle there, but they didn't have the chance to fabricate any, and so they were break bulk loading these sub-containers to then get loaded by hand on and off of the ship, which was slow. It led to a number of mix-ups with customizable orders when they got out of delivery sequence, which added a bunch of delays, a lot of extra labor. So it was considered that a insulated container would be the way to handle this. It does give quite a few advantages, especially in the thing that eventually shut the pilot program down, which was inability to maintain a cold chain. If you make an insulated box like this, yes, you can lift it on, you can lift it off, you can do all these other things with it, which are good, but you can load it with a cold source at the farm, and then you never expose it to the heat again until it gets lifted onto the bike and then goes door to door for deliveries. So in talking with Tim Boykett, who is one of the major players behind that, he kindly sketched up a much better version of this than my CAD skills allow. And you can see you don't actually lose a huge amount of space in this. The top center configuration really makes the most sense for this community supported agriculture delivery type system. You just have a little brick of ice in the middle there where you otherwise have lost space. And there you have it. So this is a reefer, and of course, a dry box would just get rid of the extra insulation space, and you have a good solid system that should work. Its major attributes are here. I won't go through all of them, but I would say the biggest thing is its overall weight of the container shouldn't be more than about 40 kilos. If you go over that, you're starting to lose much more of the gross load than it's really worthwhile. Your payload diminishes, your efficiency system wide. You start to lose these trade-offs. Aside from the pallet footprints, I would recommend two heights, one at 120 centimeters, the other at 60, and stackable 2 to 3 high. That should make them not overbuilt, but it still allows you to stack things on the dock and be space conscious as you use them. The lift on lift off is essential because it's much more efficient space wise on small ships when you're looking at a space constraint and cargo constraint when compared to roll on roll off, which is what a lot of cross harbor ferries and such are currently looking at or using. So now you need fewer ships, you need fewer bikes because they're not wasting a large amount of time and space moving these back and forth. You need a larger number of containers, but that's relatively easy. As long as the containers are less expensive than a bike or a ship, there should be an incentive to adopt these. As for a locking system, I would say just miniaturize the ISO twist lock system, and that should work. Though, of course, a professional mechanical engineer might want to verify that that is the case. A couple other variants, reefers were already discussed, but they could be very critical to that cold chain dependent shipping. The other big one is a tanker. A tank container could be up to 150 liters. It leaves you 50 kilos to mess about with baffles and drains and inlets and such. And it actually avoids a collier problem where you would be burning sustainable fuel to go pick up the feedstock for sustainable fuel. In a city where you have a whole bunch of used cooking oil being collected and then turned into biodiesel, if you run a biodiesel truck to go collect all those tanks, you're burning the biodiesel that you need for other uses. If you send a cargo bike, you just drop off an empty tank and put the full tank on your cargo bike and ride away. And you haven't burned any of your strategic material, which is your biofuel. Now, in order to handle these, a couple of additional tools would be optional, but not. They're listed here essentially. The manual lifting bars are basically just a very long bar with the twist locks at the right interval so that you can hook it in at both ends, and now you've got a way to get 4 to 8 people, depending on the length of the bar, onto this container in order to just lift it straight up manually. A lifting frame would be necessary, much like an ISO container. That's going to be a challenge because you've got multiple footprints on top. There's not like a standard width that you can just expand the length. So that one's going to be an interesting engineering challenge, but I'm sure it can be done. And for the very small, the half pallet stuff, a hand truck specifically designed with forks to handle that would be very convenient, as would a lightweight pallet jack. Most pallet jacks are made to work with over a ton. If these are 200 kilos maximum gross weight and only stacking 3 high, you could make a much lighter, handier pallet jack, which would be easier to carry aboard ship and use on the dock at undeveloped ports. Strictly speaking, though, these shouldn't need any specialized tools. You could lift them on and off the ship with just double slings and hooks. You could handle them with regular pallet jacks on the dock. You could, lift them with any number of other tools. So They don't, strictly speaking, need additional tools, but it would make the system significantly more efficient. Now, these have some additional advantages as well. If you adopt these containers for urban delivery, it actually enables other standard changes, which would make the whole urban delivery system and regional delivery system more efficient, space-wise, fuel-wise. The 5-foot urban delivery vehicle standard was developed by Rick Van Hemmen, who might actually be at the conference, and it allows you to take like a 24-foot wide road, and instead of 2 lanes and a bit of extra space, you can fit 4 lanes. So parking either side for loading and offloading, and 2 travel lanes. It's more space efficient than the 8-foot standard, and it's just much more human scale. It's going to work better with the bikes, with the LEVs, light electric vehicles, and other micro cargo deliveries that are basically being prefigured with the sustainable shifts in last mile cargo movement. Now, I propose all this specifically because last year I presented on an open source sail freighter design, and I think that this system also deserves to be open source hardware. Reason being, if this is left to anybody who decides they're going to patent their system and someone else decides to compete and patents a different system, and then someone else does the same, and there's 5 or 6 different versions of these tools and all of the hardware and the interlocking systems, then no port is ever going to adapt it. End users aren't going to adopt them, and it's going to cause a big delay, really, in getting any of these systems forward. As you may remember with the history of the shipping container, they didn't really take off until the late 1960s, and that was because the company that originally developed the container as we know it didn't release the patents for the corner castings and the twist locks until then. But once they did, it became the default basically immediately and spurred the rapid adoption of the technology. So this is one of those projects that is worth adopting as an open source hardware, making it an available standard that everyone can use, and then letting it be adopted wherever it's going to be useful. And this is a project of the Center for Post-Carbon Logistics to raise some funds and actually get these engineered, hopefully then in the next few years to get some prototypes made and get them into service. So if anyone's interested, they should definitely get in touch with the Center for Post-Carbon Logistics. I believe that's all I have. I'm a little under time, I believe. My email address is right there if anybody has any questions they'd like to address to me, but I'll open it up to the room.
Hey, that's great. Are there any questions? Yes.
Do you have any routes in mind, or would be a place to start this?
Yes. I could hear it was the question, what routes to consider?
Yes.
This would be good on the Hudson River route that Schooner Apollonia currently sails, though whether these will actually fit in the schooner's hatches, I have not yet checked. It would be very good also in the Cross Harbor or Cross Raritan Bay routes. And similarly, like a Boston to Cape Cod type route would make a lot of sense as well.
I think you should consider, there's a lot of places in the Northeast where cars are not allowed. They have freight boats. For example, Fire Island. You got a bunch of islands in Casco Bay, Maine, where there are ferries that are freight only and foot passenger only. And I think you'd be better off trying to start places like that. Trying to compete against places that have road traffic connections.
Yeah, those areas will definitely have an advantage because of the regulatory environment, but I am reasonably confident anywhere that's got bike deliveries going already will have
Yeah, you see.
Maybe not the same degree, but a level of willingness to adopt the system.
Like fire elements being handled with loose packages right now. They're handled by hand, just not that good. This should be more efficient. And you have no competition from motor vehicles.
Maybe suggestion combined with a question, the lifting of the single pallet. I think at those weight limits and for easy handling on small vessels, it might be possible to integrate a single point lift system to the pallet so that you were just lifting from an eye. Will be something stretched out to the structural frame at the bottom. Just make a pretty lightweight and easy way to install that. How it would.
I'm not sure if you heard that, Stephen, but it was suggesting a single.
I didn't hear the question, so yeah, if you could.
It was a suggestion using a single point lift system, single eye, for the lifting.
I'll send you.
That, as long as the center of gravity stays toward the center, that should work. Yeah. Yeah, that's probably way simpler than what I was thinking.
Yes.
You commented earlier on problems with hazmat and mislabeling hazmat in containers as we know them today. To what extent would this system be able to better deal with having dangerous cargoes, especially on the bicycles?
The dangerous cargoes are still going to be a risk. Mislabeling cargoes is still going to be a risk. But the volume of anything involved is going to be significantly smaller. If you have a hazardous cargo that's been mislabeled, if it's in a 12-ton unit, that's a way bigger problem than a 200-kilo unit. I think it still is something that would need to be inspected. It would need to be, checked on from time to time, just like customs and everybody else checks container loads now. But the inherent danger of it is going to be significantly less because of the mass and volume restrictions.
Okay, it doesn't look like there are any other questions, so thank you very much.
All right. Thank you.